All right, so today we're going to finish up with section 3.3 on trig identities. Yesterday we started section 3.3 and we learned these basic identities. Okay, your reciprocal identities and your quotient. Okay, I want you to remember the idea here that the three reciprocal identities on the left and the right, they're repeats of each other. Okay, they're just rearranged a little bit. Okay, we're gonna do that same idea again today. Okay, and the last three identities we're going to look at are called the Pythagorean identities. And they're called the Pythagorean identities because they kind of look like Pythagorean theorem a little bit. Squaring two things and adding them together, like a squared plus b squared. All right, so we get sine squared plus cosine squared equals 1. Okay, that will always be true. Okay, let me show you. Somebody give me an angle, any angle. 25. Okay, so if you take the sine of 25 and square it, take the cosine of 25 and square it. When I hit enter, what did the formula say I'm going to get?
1.
I'm going to get 1, and I do. I get 1. Okay, that'll work for any angle. That's why it's an identity. It's always true. Okay, let me show you a different form of that same identity. Okay, I'm going to take and subtract cosine squared from each side. What that does is it cancels out cosine squared on the left. And now all you have is sine squared. And that's equal to 1 minus cosine squared. That's not a new identity. That's the identity I just showed you, rearranged a little bit. Okay? And you could have rearranged it by subtracting sine squared from each side. Okay? I'm not going to rewrite every single identity every single way it can be written. Okay? Because that's gonna add a lot of extra stuff. But I just want you to understand the idea that identities can be rearranged. Any question on how this comes from the original identity? Okay. All right. Let's take the identity we have up above, and let's divide everything by the same thing. Which one? Yeah. Let's divide everything by sine squared. Okay? And watch what happens. Okay? This part you can just watch. Okay? Just leave identity 1 the way you had it. Just watch what I'm doing. And divide by sine squared. What do you get if you did sine squared divided by sine squared? Okay, if you divide two things that are the same, you get 1. Now this we talked about yesterday, cosine squared over sine squared. We don't have an identity for that directly, but I did mention that. You can use those identities with higher powers. So what do you think cosine squared over sine squared would be?
Cotangent squared.
Yep, it's cotangent squared. Cotangent squared. And let's look at one more. We have 1 divided by sine squared. Okay, well, we had an identity for 1 divided by sine. It's cosecant. What do you think 1 over sine squared would be?
Cosecant squared.
It's cosecant squared. And by dividing everything through by sine squared, that gives us our second trig identity. 1 plus cotangent squared equals cosecant squared. Any questions on the second identity? And just like the first one, that can be rearranged as well. You could subtract cotangent squared from each side and say 1 equals cosecant squared minus cotangent squared. Okay, but we're not going to go through all the ways you can rearrange it. All right, let's go back to the original identity one more time. This time, let's divide everything by, what did we do last time? Sine squared? Let's do cosine squared this time. Okay, and again, just watch this part. Okay. What do you think sine squared divided by cosine squared is? That's tangent squared. Plus, cosine squared divided by cosine squared is 1. Dividing two things that are the same. And lastly, what about 1 divided by cosine squared? That's secant squared. And that brings us to our third trig identity. Tangent squared plus 1 equals secant squared. Okay, what I did on step 1 that I just asked you to watch, that's how you get the identity. But now that we have it, you don't need to get that ever again. Okay, just add them to your list. And that's it. Those are the last 3 identities that we're going to need. As I said yesterday, that's not all the trig identities. There's hundreds or maybe even 1,000 trig identities. We're doing 11. Okay? There's a lot of different kinds of identities. All right, so the idea of verifying an identity, you guys did that on the homework last night. Okay, the difference between verify and simplify. Simplify, they just give you an expression and they just do what you can to make it simpler. Verify, they're going to give you something on the left. They're going to give you something on the right, just like you had in the homework. So you kind of know where you're going to start and where you have to end up. And somehow you have to show that the two sides are equivalent. Generally, what you want to do is take whichever side is more complicated and start with that. It's easier to take something that's complicated and cancel stuff out, rather than take something that's already simple and try to just magically add stuff back in. Okay, that's harder to do. So we'll always start with the more complex side and try to cancel things out.
You said when we are asked instead of when we are asked.
When we are, thank you. When we are asked. Okay? Any question on what verify means? Okay, I'll try to set up some of the problems in the notes today like we did on the homework last night.
Kind of prove true.
Yeah, it's like prove. I try not to say the word proof because that usually scares people. But yes, we are doing proofs all week. But I didn't say that. It's not the kind of proofs you do in geometry though, so they're very different than that.
Those are terrible.
All right, so here, they give us an expression on the left. They give us something on the right. And we have to prove somehow that those are both equal. My suggestion is to start with the side that looks more complicated. In this case, would that be the left or the right? Yeah, the left side. Okay, left side is definitely more complex. Right, we're going to use all the same tricks we already know. Change to sines and cosines. Look for a common denominator. And use the conjugate. Don't forget about the basic identities we learned yesterday, in addition to the 3 that we learned today. Okay, anybody have a suggestion what I could try to start out doing on the left-hand side?
Change the cosecant.
Yeah, let's change the cosecant. What do you want to change it to? Yeah. As I said before, at this point, I'm not going to write the argument anymore, just to save us a little writing, but the argument is understood to be there. Okay, so we have sine times 1 over sine minus cosine squared. Now what happens here when you take sine times 1 divided by sine? They cancel out. If you're not sure why, just go like that. What are you left with before cosine squared now? You have a 1. 1 minus cosine squared. Anybody recognize that? It's not directly something we wrote, but it's a version of it, yeah?
Equals sine squared.
That is sine squared. Remember this identity. All they've done is they've taken and moved cosine squared to the other side. In fact, I think we did that. Sine squared is equal to 1 minus cosine squared. So to get from this step to that step, we used the Pythagorean identity. Which one did we use? I think it was the first one. Any question on how we changed 1 minus cosine squared to sine squared? And that's it. So we get sine squared on the left, and that's what they wanted us to end up with. All right, so that would be considered an easier one. Okay, that's a quick one with using a Pythagorean identity. Okay, maybe we'll do like one that starts to get kind of tough, but a lot of them will stick with like easier, kind of medium. Any questions here? All right. And just because we learned the Pythagorean identities, doesn't mean you're going to use one in every problem now. Maybe we'll use one here, maybe we won't. I don't know. We'll start solving it and see what happens. All right, so we've got sine times cotangent plus tangent in parentheses equals secant. Ashley, any thought that we could try here?
We change them to sine and cosine.
Yeah, changing to sines and cosines, usually that's all a good idea. Okay, try it and see what happens. Okay, let's start with our cotangent. Amy, if we change cotangent, what does that change to? Good, cosine over sine. Plus, now we need to change tangent. Tom, what does tangent change into? Yep, sine over cosine. And remember, the right-hand side, that's just what you want to end up with. So just leave that alone. Sometimes we have problems where we start changing the left and the right side at the same time. But that's a little more advanced. That can get confusing. So I'll probably leave the right-hand side alone for most problems. Okay, what property could we use now? Get something on the outside and then parentheses next to it. Yeah, let's use the distributive. If you want to think of what you're distributing as a fraction, it's sine over 1. Okay, so let's write that out. So we have sine times cosine divided by sine plus sine times sine divided by cosine. Okay. What can I do now? Yeah. Yep, which, the two that are on the right at the top? On the left, yeah. Common factor, top and bottom, multiplication, cancels out. Let's see what we're left with. Cosine plus sine times sine is sine squared. All right, so we have everything as a sine or a cosine, but we haven't got the answer they want yet. They want us to somehow get secant. Hey, any suggestions what I do now? We're going to have to use another trick we learned yesterday. Yeah?
Multiply the cosine over 1 times, like, the denominator and numerator of times, like, cosine.
Yeah, what are you trying to do here?
Make the denominator equal the other denominator.
Yeah, we're trying to get a common denominator. We have two fractions with different denominators. To add them together, make it a common denominator. Okay, and she told us exactly how to do it. Common denominator here is going to be cosine. That means the fraction on the right is fine. It already has a denominator of cosine. It's not going to change. The one on the left doesn't. It has a denominator of 1. How would you make it have a denominator of cosine? Bless you. You'd have to multiply top and bottom by the same thing. In this case, cosine. Cosine times 1. There's your denominator of cosine. What's cosine times cosine? Cosine squared. Okay, now what's going to happen? You have cosine squared plus sine squared in the top. Yeah? Why does the numerator equal 1? Yeah. The numerator is your first Pythagorean identity. We wrote it as sine squared plus cosine squared. Cosine squared plus sine squared is the same thing. It's just rearranged. So this entire numerator cancels out and becomes just a 1. And lastly, now we have 1 over cosine. What do you get when you take cosine and flip it? Yeah. When you flip cosine, you'll get exactly what they have on the right-hand side. If you're not sure, just go look it up. Flip cosine and you get secant. So now we made the left match the right. And we're done. Okay, so that's more of a kind of a medium. We had to do the common denominator trick. We had to change the sines and cosines, use the Pythagorean identity, a reciprocal identity, and the distributive property. So there was a lot of different things we did there. Any questions on that one? Let's look at this one. It says tangent plus cotangent divided by secant times cosecant. Somehow that's going to cancel out, and everything's going to cancel out. It's going to become a 1. Okay, so to start this off, I would probably use one of the same tricks we've been using over and over. Yeah, let's change everything to sine and cosine. That's going to give us a lot of fractions, but again, hopefully somehow a lot of stuff is going to cancel out. So let's start off with tangent. Tangent becomes sine over cosine. Plus cotangent. Cosine over sine. Now, just looking at what I've done so far, to me it has a little bit of a similarity of this problem. Okay, where we had a sine, we had a sine squared over a cosine, and then we had a cosine in the other fraction. It's kind of similar, and I think we're going to end up doing the same thing we did here, maybe a common denominator. Right? And then let's look at what we have in the bottom. Secant. It's 1 over cosine. And cosecant, 1 over sine. All right, for most of this problem, I think I would leave the denominator alone. what's going to have to happen to the numerator? If somehow we're going to get 1, the numerator and the denominator in a fraction, what's the relationship between them if you get 1?
It's the same in the numerator and the denominator.
They're the same. So somehow we're going to have to make the top and the bottom the same. That's the only way you can divide two things and get 1. Let's leave the bottom, just copy it over the way it is. In fact, I don't think it'll change for the rest of this problem. We're just going to work with the numerator. What trick could I use here? Can't change the sines and cosines. We already did that.
Common denominator.
Yeah, let's find a common denominator. What would your common denominator be?
Cosine times sine.
Cosine times sine. Look what we have in the bottom, cosine times sine. So that's a hint that maybe that's how we can make the top look like the bottom. Okay. So cosine times sine. In fact, if you wanted, you can put the denominator together just like that. Or you can leave it the way we had it. You just put it together, cosine times sine. If you don't do it at this step, we should just do it in the next step. Okay. Let's look at the fraction on the left. Okay, Sean, the fraction on the left has a denominator of cosine. What's it missing to have the common denominator?
Sine.
It's missing sine. So let's get the sine in there. Multiply by sine over sine. Before we do that, let's look at the other fraction. Zach, the denominator here is sine. What's it missing?
Missing cosine?
It's missing cosine. So let's get that in there. Let's multiply by cosine over cosine. Okay, so denominator is sine times cosine, or cosine times sine, same thing. What's my numerator become on the left? That's sine squared. What about my numerator on the fraction on the right? Cosine squared. And now, because of our Pythagorean identity, sine squared plus cosine squared, that equals 1. So all of this is going to become a 1. So we get 1 over cosine sine in the top, and we have the same thing in the bottom. 1 over cosine sine. What do you get when you divide two things that are the same in the top and bottom? 1. And that's it. We've proven what they wanted us to prove. So everything canceled out and became a 1. All right, so we changed to sines and cosines, found a common denominator, and used a Pythagorean identity. I don't think there was as much involved in this problem as the last one. So maybe this one was a little easier, but not super easy. Not too bad. Hey, any questions on that one? All right, let's... All right, why don't you try that one on your own? It says cosecant minus 1 times cosecant plus 1 equals cotangent squared. This won't be a bad one. And by not bad, I mean you can do it in probably less than 3 steps, maybe 2. Okay, so the left-hand side is definitely more complex. Try to do what you can there and see if you can somehow end up with what's on the right. And it will involve one of the new identities we learned today. Okay, that's a hint. Okay, so give that a shot and I'll walk around and help you out. All right, so one thing that I saw is some people saw a -1 and a +1 and they tried to go like that. Well, you can't cancel those out. Okay, just like if you had x plus 2 times x minus 2. You can't just cancel those out and say, oh, it's just x times x, which is x squared. That that doesn't work.
Forget about the 2 minus 2, basically.
Yeah, what's the name? What do you have to do here? Yeah, distribute it out. You have to FOIL it, okay? And the other reason why I would FOIL it is because these are conjugates. Cosecant minus 1, cosecant plus 1. Anytime you have conjugates and you can multiply them together, nice things are going to happen. You're always going to get some stuff that just disappears. All right, so let's FOIL those or distribute them out and see what happens. Let's start with cosecant times cosecant. What does that give me? Cosecant squared. Okay, now just watch the next part. Don't write this part down yet. We have cosecant times positive 1. We have cosecant times negative 1. What happens there? Those cancel out. You get positive cosecant, negative cosecant. And then lastly, we have negative 1 times positive 1. Okay, we get negative 1. Now, let's go back and take a look at the identity. We had an identity that has a cosecant squared, it's got a cotangent squared, and it has a 1 in it. Let's see if it was written exactly like that or maybe a little different. Okay, let's copy it down. 1 plus cotangent squared equals cosecant squared. So 1 plus cotangent squared. So it's a little different than what we have. Oh, 1 plus cotangent squared equals cosecant squared. Thank you. Is this identity really the same thing that we have up above? Yeah. Okay. Watch what happens if you go like this. I'm taking our basic identity, and I'm going to move the 1 to the other side. And I get this. Cotangent squared is the same as cosecant squared minus 1. It's exactly what we have right here. Cosecant squared minus 1, it's exactly the same as cotangent using a Pythagorean identity. And that's it. That's the whole problem right there. Okay, the other trick I saw some people try was changing to sines and cosines. Again, I already mentioned that in this problem you can do it. It just doesn't make it easier. That's the best way to do this one. All right, any question on that? All right. And let's finish up with this one. All right, so this one they give us 1 minus sine over cosine on the left, and cosine divided by 1 plus sine on the right. Which side looks more complicated? Yeah, they're both pretty much the same level of difficulty. So it doesn't matter which side you start with this time. You can start with what's on the right, try to make it look like the left, or start with what's on the left and make it look like what's on the right. Let's take what's on the left. 1 minus sine over cosine. How about changing to sines and cosines? It's already done. Okay, so changing to sine and cosines, that won't help. How about a common denominator? Will that work? Have I written down something that has 2 different denominators right now? No. There already is a common denominator. It's a cosine. So what's the only trick we have left? The conjugate. And another hint that you might want to use the conjugate, look at what's in the numerator. 1 minus sine. Look what's in the answer, 1 plus sine. The answer has the conjugate in it. So why don't we try using the conjugate and see what happens. Okay, so multiply by 1 plus sine over 1 plus sine. let's do out the top. So we're going to get 1 times 1. Naisha, what's that give me? Yeah, just 1. We get 1 times positive sign, 1 times negative sign. Those cancel out. Kyle, what's a negative times a positive?
Negative.
Yep, good, negative. And then sine times sine? Sine squared. Now how about the bottom? Should I do it out or just leave it the way it is? Yeah, kind of the way I said that, you could probably tell. But the reason I want to leave it the way it is because something's going to happen in the top to cancel something in the bottom. Okay, so just leave the bottom the way it is. It's cosine times 1 plus sine. Okay, and let's take a look at the top. 1 minus sine squared. Does anybody recognize that? Yeah?
It's the first Pythagorean.
Yeah, that's the first Pythagorean identity. What is 1 minus sine squared? It's cosine squared. Okay. If you need to, just write it down and look at it. That's the identity the way I wrote it. Take sine squared, put it on the other side. It'd be cosine squared equals 1 minus sine squared. So 1 minus sine squared is cosine squared. If you don't see that that numerator is a Pythagorean identity, you can't do this problem. You have to recognize that. And then in the bottom, 1 plus sine. Okay. How many cosines do we have in the top? Yeah, we have cosine times cosine. How many cosines in the bottom? Just 1. So how many do the top and bottom have in common? Just 1. So you can cancel 1 from the top and 1 from the bottom. And look at what you're left with. Cosine divided by 1 plus sine. Go back up and see what they wanted you to get. Cosine over 1 plus sine. That's it. Any questions on that identity? All right, so don't get discouraged if you get stuck and it gets kind of tough because identities are a tough topic. They're not an easy topic. All right, that's why we're going to spend a whole extra day tomorrow just reviewing. All right, so tonight's homework, that'll be in the book. On page 199 goes on to 200. Okay, 9 to 14 all, and 19 to 27 odd. Okay, some of the problems in the book, they give you something like this, and then they just give you a direction and say, do this. Like they'll say multiply top and bottom by 1 minus sine. So you're not actually verifying an identity. You're just doing a direction they asked you to do. And that's it. Okay? But then I think 19 through 27, those are proving identities.